This is Mr. Agbamu Idonogwene. In today's class, I'm going to teach us the basic of differentiation in calculus. And what my target of today's class, which are my objectives, are to explain the meaning of differentiation and to derive the derivative of a function. Okay, so let's start with what is differentiation. In mathematics or in general science, we have some situations whereby a particular quantity will change with respect to another quantity. If you recall what we did in our previous class in coordinate geometry, when we were talking about gradient, you will observe that in gradient, when one of the quantities is changing, it will affect the other quantity. That is why we say gradient is increase in y divided by increase in x. So when we say increase in y, we are talking of how is y increasing with respect to the increase in x. So that is why we said gradient in our previous class. Gradient is simply increase in y. That is where we have our y2 minus y1. Then we now divide it by x2 minus x1. So this is it. So how is y changing with respect to x? Let's take an example. Let me demonstrate the meaning of differentiation using this example. Let's take an example with let's say y is equal to, let's take something like 2x plus, let's say 2x plus 3. Let's take this as a function. You know this is also a line, and the gradient of this line is 2. And that is the meaning of differentiation. So differentiation is simply the gradient of the function. So when they tell you to differentiate a function, what they are indirectly telling you to do is to find the gradient of that function. If you can find the gradient of that function, you have already differentiated it. So that's what they are indirectly saying. Then if I say differentiate y equals to 2x plus 3, all I'm just trying to tell you to do in this line, in this equation of a line, you know this is an equation of a line if you go through our last class. All I'm trying to tell you to do is to find the gradient of this function. I know that the gradient of this function, which is gradient now, the gradient is equals to 2 based on the general equation of a formula or equation of a straight line. You know, we take the coefficient of x. It's the coefficient of x that will give us the gradient, which is also the differentiation when you differentiate this function. So what does this mean in differentiation now? In differentiation, we are trying to see how is y changing with respect to x. Let me show you the line of this equation. Let's go to our graph. Let me demonstrate it here. If I have y equals to 2x plus 3, you can see this is the line. So that is the line now. So if I take a point, let's take a point on this line. Let's take a point. Let's just take this point. So if I take a point which is minus 1 for x and 1 for y, that means when x is minus 1, what is y going to be? That's what we are talking about. When x is minus 1, what is y going to be? Y is going to be 1. That's why we have minus 1 and 1 here. You know, when you substitute 1 in this place of x, 2 times 1 will give you 2 plus 3, which is 5. So that means when x is minus 1, sorry, when you substitute minus 1 in this place, you have 2 times minus 1, which is minus 2. Then minus 2 plus 3 will give you 1. So when x is minus 1, y is 1. So what differentiation is talking about is if y is now moving along this line. See, if y is moving along this line, so how is that if this point A now is moving along this line, you can see as I'm moving it along now. So how is y changing with respect to x? You can see the values are changing here. You see as A is moving, just be looking at this place. As A is rising up, you can see the values of y is changing as far as the values of x is changing. So let's move it to this point. Let's see. So now we are here now. So when x changes, when point A changes its position from this point here to this point, you can see that x changed from -1 to 1. So this is the short distance here. X changes from -1 to y. How does y change now? Y changes from 1 to 5. You can see it. So that is the changes. So that is why we use gradient. We say whenever you are asked to find the equation of a straight line, whenever you are asked to differentiate a function, all we are just telling you to do is to find the gradient of that function, which is this. So this short distance from this C to A now is the change in x. Then this short distance from B to A here is the change in y. So this is what we do in differentiation, just to get the gradient of the function. So this is just some basic explanation of differentiation. Since you have a good knowledge of coordinate geometry, differentiation is not going to be a difficult topic for you. You will easily understand it, and it's easy. Okay, take note of that. Alright, so if we say gradient is this, and remember we said, let me use m as my gradient. We said this is gradient. So this is gradient now. Then remember what I said we are doing in differentiation. Now we are checking the changes now, change in y and change in x. If I put a statement that if I say let delta now, so let delta y, let it be equals to y2 minus y1. So let's take this as delta y. Okay, so we take this as delta y, and let's also take this, let's take this as delta x also. So delta x, let delta x also be equals to x2 minus x1. Okay, so that is the changes. Like, this is what I'm talking about. Like this change that occurs in this place. See the changes from this point to this point, which is x1 to x2. X2 minus x1, this is the changes we are talking about here. Then y2 minus y1, so this is the changes we are talking about here. So this dy, this is delta y, while this is delta x. So these are just the changes that occurs in the function. Alright, take note of that. But let me make x2 the subject of this expression here. If I make x2 the subject here, I'm going to have x2 is going to be equals to delta x, well, which is x1 plus delta x1 plus delta x. Okay, so you have this now. Then let's take a function. Let me come to this place. Let's take a function. Let's take y as a function. Assuming I have y, let's take it as an assumption now. Let y equals to f of x. Okay, so let's take this function now. Assuming you are asked to differentiate this function, let y equals to f of x. So this is a function. Then in this assumption here, let's also take the first point. So let's take the first point. So if I take y1 as our first point, so let's take y1 as our first point, which is y1. So y1 will also be equals to f of x1. Okay, you agree with me? Okay, So let the first point, you know what I mean by the first point? I'm talking of this first point. This is x1, y1. x1 is minus 1, then y1 is 1, then x2, which is this place, 1, then y2 is 5. So this is what I'm talking about. So take note of that. So let's just take y1 to be this. So y1 will produce x1, or x1 will produce y1. So also if I take this, so if I take for the second function also, which is y2, so also y2 is going to produce f of x2. So that is one thing I want you to take note of. Okay, so then looking at our changes now, the change in y and the change in x, we define it as delta y and delta x. So you can replace this value now. We said x2 is x1 plus delta x. Let's replace x2 in y2 as this. So now y2 is going to give us f of x1. Need a small letter here, f, then you open your bracket, x1 plus delta x. So you can see it. So x2, you just replace x2 with x1 plus delta x that you got in this place. You put it down here. So that is that. Then the next thing we need now is, let's go to our gradient function, which is m now. So if you substitute into the gradient function, which is this m, so you are going to have m will be equal to, what is y2? You can see your function for y2, which is f x1 plus delta x. Then what is y1? y1 is the function itself, which is f of x1, then divide. Then what is x2? We say take ds as x, and take x2 minus x1 to be changing s, which is delta x. Then you just call it delta x. So this is it. So this is it. So this is the differentiation now, which is called the derivative function. So this is the derivative function now. But if let me represent it in the form that we use in differentiating now. If you want to differentiate, we usually use dy dx, which is small letter d of y divided by small letter dx. So how do you represent that now? What you need to do next is, if you study this graph very well, you will discover that when this point A, it was there when I started the explanation, as it's moving closer to this point, this value is changing. Let me demonstrate it using this animation I have here. You can see delta x, this point is delta x. You can see, so when point A, you can see the expression we just derived now, f of x plus x dx, delta x minus f of x all over the delta x. So it's the general derivative function when you are asked to differentiate a function. Then if you move A, just watch as A is getting closer. See, as A is approaching B, see, as A is moving along the line, it's approaching B, watch, see, delta x will be approaching 0. Just watch, will be going closer to 0. When A was here, you see, this is 0.37. As A is going closer to B, see, as it's going closer to B, you observe that delta x is changing values and is approaching 0. See, it's approaching 0. You can see what is happening. See, it's going to 0. So now 0.08 is approaching 0. So it's going closer to 9, 0.04, 0.01. You can see. see now when it approaches B is tending to 0. So because of this idea now, when point A is approaching now, which is now the change now, as A is moving towards B, you know that Y is changing with respect to X. So as it's going towards B now, you discover that delta X is changing, it's approaching 0. So since it's approaching 0 now, what you need to do here now is just say this value now, which is M now, this value M, you know, is a gradient, which is a change in Y, which is same thing as delta okay. So M, which is the same thing as delta Y divided by delta X. Understand? So gradient is the same thing as this. So this value of M, will now be equals to f of x. This time around we don't need to put x1 in this, we just call it x plus delta x, then plus minus f of x minus f of x divided by delta x. So that is it. Then as point A is approaching point B now, as you are changing, as the position is changing along the line, you discover that this delta s is approaching 0. So what do we do in that case now? You now take the limit. So you take limit, then this value now, this limiting value, which is dy dx, which is dy divided by dx. So this is now the differentiation now. So dy dx value will now give us the limit of this value, which is this, the limit of delta y divided by delta x when delta x approaches 0. So this is the derivative function. Yes. So what you need to do now is, when they ask you to differentiate, most times this is what we do when they ask you to differentiate from first principle. When you are asked to differentiate a function from first principle, let's say y is equals to a value, all you need to do, you can follow this approach. After following this delta y and delta x approach, you get to this stage. The next thing is, when the delta x approaches 0, you can see from the graph I demonstrated the other day, as you are changing the position of the first point A towards B, you can see that delta x is approaching 0. See, it's tending towards 0. So that is what this limit is talking about. So the limit of delta x as it's approaching 0, then you need to substitute it in delta x, you now get your 0. Then from there, dy delta x over delta x will now be equal to the value of your differentiation. So whatever you have in this limit will give you your answer. So this is what we need in our differentiation. So let me put it in box so that you will take note of it. So it's very, very important. So take note of this value of differentiation. So this is all I want us to achieve today. So this is what I call the derivative of a function. So this is the derivative of a function. In our next class, I'm going to solve an example from first principle. So when they ask you to differentiate from first principle, this is all they want you to do. Differentiation from first principle. Your value for y, they just want you to replace it with delta y. Then value for x, replace it with delta x. Then you now substitute the changes you have here. Then you solve down. When you get to this value for your gradient, then get the limit when delta x approaches 0. Then whatever answer you have, that will be your differentiation, which is pronounced as dy dx. So this is the introduction to differentiation using your derivative of a function. So in our next class, I will do example on differentiation from first principle using this approach we just explained. So that is all I have for you today. So till we meet in another class, do have a nice time. Take care.